In recent times, Twitter has become one of the most important communication platforms around the world, and in times of need, people have often turned to Twitter to both plead for help and to raise awareness. An example of this was during the Australian wildfires, where over 1 million tweets were sent out about the disaster. As a result, emergency teams around the world have started monitoring Twitter in order to provide help with greater efficiency.
In order to obtain relevant tweets, emergency teams have to extract tweets using keywords such as fire, ablaze, floods, earthquakes, and so forth. The problem with this extraction method is that although most tweets may contain a keyword of interest, not every tweet with that keyword is reporting on disasters.
An example of this is this tweet, where the Twitter user is tweeting about Eden Hazard, the soccer player, instead of a real hazardous fire. Also, the volume of tweets that are sent out are overwhelming for emergency teams to manually evaluate and classify which ones are reporting on disasters.
Since modern-day problems require modern-day solutions, over the past few weeks we have been investigating and implementing machine learning-based solutions for determining whether tweets are reporting on disasters or not. Having been provided with a dataset that consists of tweets, the location from which they were sent, and labels as either real or fake, our general approach for this project was to investigate different feature extraction techniques along with different neural network architectures. Upon analysis of our data, we found that there was an imbalance in the ratio between real and fake tweets, and so we decided that the best performance metrics to evaluate our models are accuracy, precision, recall, and the F1 score. Since computers do not understand language the way humans do, processing tasks such as stop-word removal were first carried out on the text. The tweets were then transformed into one-hot encodings and word embeddings. One-hot encodings were found not to capture semantic information within text, while word embeddings did. As a result, word embeddings yield a better performance in comparison to the one-hot encodings as illustrated in this table.
The one-hot encodings and word embeddings were fed into neural network models for training. The first neural network architecture investigated was multi-layer perceptron, and it was found that it does not capture relationship between words in a sentence. An architecture that captures relationship between words in a sentence is recurrent neural network. However, it suffers from a problem of vanishing gradient when dealing with long sentences. LSTMs, which are a variant of recurrent neural networks, were found to solve this problem and managed to yield a better performance as illustrated in the table.
To put our models to the test, we used Twitter's API to extract tweets from Twitter and classify them in real time. And here are the results which we obtained.